So let's take a look at this, and we'll cover. It's basically, if you look at the menu, it's just the basics. Everything beyond that, graphics and intermediate, ignore. Uh, we're talking about loops, numbers, variables, if statements, strings, which are characters of text, lists, more lists, while loops, dictionaries, text files, that's the CSV files, functions, object-oriented programming. That's it. That's what you need to know in a nutshell to get going with Python. There's a key strategy, again, because even these 14 chapters is very overwhelming. We're talking about 133 pages. So it's a lot, I get it. Here's what you need to know. When you are learning these, my recommendation is read it from top to bottom. If you get confused, keep going, keep reading, just keep going, because a lot of times the way it works is by the time you get to chapter 12, 13, and 14, it will click in your head and you'll say like, oh my gosh, I understand chapters 1 through 6 now. So you can always reread it if you want. I don't think you need to reread it. I would say just slam through the syntax one time, just really give it a one good time in your life, go through the syntax, really understand what makes a programming language, and then move on to practical applications. Ultimately, with a programming language, it's a tool. You're really going to only use the tool when it's applied to a context. So work with me to find projects that are useful. In lieu of that, I know a number of people who open ChatGPT and say, give me some example Python projects to get going with, and it will recommend some ideas for you. So either way, the goal of the learning process is to quickly get into applied projects, and then just try things out. That's really the only way to learn languages. There are videos, so if reading is just not your thing, videos, online courses. I'm available individually for personal mentoring, so I can spend some time with anyone on this call or anybody watching this recording for the next few years. Book some time with me, and I will work through where you are, and we'll make some progress. But just try and adapt it for what's best for you. I recommend this. One of the main reasons I recommend it is because as you're going through it, you know exactly where you are. You're 25% done, 50% done, 60% done. You're keeping up with where you are, and it's easy to jump back and forth. I find with videos you're a bit lost. You don't know what's coming up next. It's this black box, and so that I think there's a little bit of superiority to that. I'm going to not do installing it. You guys need to just figure some of that out yourself. That's becoming comfortable with installing programs and also libraries that Python depends on. Just start trying, have it not work for a while. And then basically with all programming, you only get good at programming by running enough into every single possible thing that could go wrong. You get it wrong once, and then next time you encounter it, you know how to deal with it. So just have as many problems as you can, because that's really how you get better. So let's go ahead and get into Python. So first of all, what I recommend is starting Python from command line. So for anybody who doesn't know, an operating system is what the computers use. An operating system fundamentally is one program running in the background that runs other programs. That program is always called a kernel. So Windows has a kernel, Linux has a kernel, Mac has a kernel, and it is the thing that controls all of your system resources, your CPU utilization, your RAM, your memory, what has priority, and it is the job of the kernel to multitask. So between all of your programs, it has to time balance. Historically, you would only have single core processors. And what a core is a piece of microchip that runs a known number of instructions. And instructions are binary operations that are things like add, subtract, multiply, move data from A to B, load, and compare. That's like the huge majority of all the operations, just arithmetic, moving data, and comparing data. And if you've ever heard of like a 64-bit computer, what it's talking about is those 64 bits are the size of the data that each CPU instruction is looking at once. So if you're adding 64 binaries, 64 binary values to another 64 binaries, resulting in a 64 binary. Like all of the data is represented at 64 bits. Used to be there was 32 bits, before that 16, before that, as low as 8, and then before that, in the original invention, there's all kinds of weird ones. You can ignore all that. It's all 64-bit now, for the most part. But just know that it's the role of a computer, and it's the role of software to break your instructions, which you're going to write in your programming language, down into instructions that the CPU runs. The CPU is translating software into a sequence of operations that runs on the CPU. So when you write a program in Python, or used to be you'd write it in C and C++, in C and C++, you would compile it. So you're taking basically human language, turning it into what's called bytecode, which is just like the way the computer is able to work with it so that the CPU can handle it. And then what the CPU is doing is just running through a sequence of instructions. Some of the instructions are branching instructions. So if 1 is greater than 0, then jump to this instruction location, instruction 1, 2, 3. If 1 is less than 0, then jump to 5, 8, 9 location in memory. And so with that basic concept of like you're just able to have basically if loops and if statements and jumping of where the data is, that's what all software comes down to. So a little bit, I would say, as you mature, you don't need to know a lot of like, oh, this is how CPUs work when you're starting programming, but starting to become familiar with how a computer is built, it will become more and more helpful over time. You certainly will run into like limitation and constraints when you move into like big data. So if you fast forward your career track, you're running thousands of genome sequences in this massive server farm, AWS, Google Compute Cloud, whatever it is. At that scale where you're spending millions of dollars on big data processing, having an intimate understanding of what your resource constraints are, it's important. So, we'll focus on syntax today. So all programs, so you start with the command line. The kernel is the operating system behind the scenes. You kind of have the kernel, which runs everything, and then you have programs that run on top of the kernel. It's like the user is running the program, the operating system is just controlling which user programs are running when. The command line is how you launch programs. Basically, you can think of the command line as the operating system behind the scenes, like all these Windows and Firefox and Google and all these Slack and all these things. You can just imagine that there is a way that you're calling a function here, and so I'm going to write something and press enter. I'm going to write Python enter, and I've launched the Python program. Let me go ahead and make that a little bit bigger. Now I'm inside this program, so this program is just running. I can do things like print hello world, and it responds and it does something. Print the string value of 1 plus 4, 5. So we're doing stuff. I'm going to go ahead and exit out of Python. It will return me to the command line. And so when I ran this Python command, this is just a convenience feature. What you need to know is that what's actually going on is that you are actually literally calling an executable file. Let me see where my python.exe file is. In Windows, exe is the executable format. So let's say I have a few of them. Let me pick this one. So I have a Python exe somewhere on my system. It happens to be in C program files, Python 3.11. So when I do Python enter, what it's doing by convention is it's actually looking for a Python.exe file. The .exe is implied because when you run programs, you're running executables. So the very first thing you always pass is an executable. After you run that, after you specify an executable, often this is where parameters go. And so often, like, you can put could put anything here, but a lot of times you're going to do like the name of the file, so my file.py. So you're passing a value into the executable, but the very first thing is always an executable. Now, just for general knowledge, be aware that what's really going on behind the scenes is Python enter up here is equivalent to this thing that I'm doing right here, which is hard coding the actual path. In fact, that's what I'm actually doing. All modern operating systems have this concept of paths, where when you type the name of a program, it will search in common locations for that. And if it finds it, it will automatically call it. If it doesn't find it, so like made up thing, it's going to say not recognized, not a command. So Python is recognized because it exists in a folder that the system knows about. That's the path variables for folks interested in the detailed stuff. But in any case, when you install Python and add it to your path, this is what you're doing. You're making it accessible here. So at this point, let's go ahead and jump into Python. I recommend calling it from command line. It's the best place to start. There are things that it installs by default that I don't recommend. There's this thing called idle. Any tutorial that tells you to use idle, I say ignore that. I don't recommend it. There is a Python program proper that, like, if you just launch it, it looks like a command line, but it's like it just skips to being in Python and exit just closes it. That's okay. Either one is fine. I still recommend the command line, the command prompt, and just we'll get into that whys later, but it has to do with when you work with projects and you have other files involved. All right, so now we're in Python. So if you notice, there's a few things in the old Windows command prompt. You had a path. This is like a folder path or a directory. Just as far as nomenclature, folders are what Windows calls it. Directories are what Linux calls it, and Mac, I think, too, maybe. Doesn't really matter. They mean the same thing from our perspective. Generally, an operating system starts from a root location and then goes down. In Windows world, it's almost always the C drive. In Mac and Linux, it's actually this forward slash means the root folder for the operating system. So it ends in this little character here, and then you start typing. And so there's always normally a character that shows you, like, this is where you start typing your text. Normally it's this greater than sign. Here you see 3 of them. Telling you kind of where your cursor is. Just be aware of that. If you see that, you know that you're probably in some interactive terminal. All right, so the very first program that everybody does is a hello world. This is just convention. So print is a function. A function is a set of code that does something for you. This is a very simple one that just returns text to the terminal. You'll notice that the text that's returning is inside double quotes. Double quotes are a convention for how you wrap your letters. You can put anything in there. Technically, you can use single quotes. Hello, Moon. That technically works. However, for historical reasons, normally you only use those for single characters. So best case is my character equals A. That's convention. My string equals more than one character. So strings here are referring to sequences of alphanumeric characters. And then you can do something like print. Now, we've also introduced the concept of variables. So variables hold any value, and you refer to that value by its variable name. You come up with the variables yourself, however you want it. I think the main thing is that it has to start with a character, and you can't have like weird special characters in there. I think you can have underscore, but you can't have like a star or anything. Like those are very meaningful. So basically, don't start with a number. Don't use weird characters. Don't use any of those. But you can use upper, lowercase, and underscore. At this point, I have a name that refers to the value that I initialized. So I'm initializing a variable to a value. So I can call again a function and pass in my variable. So I would say I'm going to build a concatenation of string-like objects. I'm going to do my character. I'm going to say add that to a space, just an empty space, and then my string. And you see that it builds that kind of final string for me, and then it prints it to the prompt. So character is basically strings are a very primitive type in Python. Another very primitive type is integers. Integers are round whole numbers. So my int equals 4, my other int equals 6, and you could say result equals my other int minus my int. I now have a variable that's holding the result value, but I haven't done anything with it yet. So at this time, I will print the string version of result, and it's 2. I've also introduced a second function here, string. You will encounter as you're learning Python a number of reserved words that already mean like functions. There's maybe like 50 of them that are like really important. You'll just learn them very easily. It's not that many. Stir is one of them. Print is one of them. We'll cover others as they come up. But that's another basic variable type. Now, there's obviously, now that we have integers, you might be asking about decimals. Decimals exist. They're referred to as float. So we'll say my float equals 3.14. And if we were to do my int equals 1, so first of all, you'll see that my int used to be 4. Now I have overridden the value of the my int label with this new value. So I have my float 3.4, my int 1, and you can do multiplication. So print my float times my int, and what you see is that the result is still a float. So a float times an int preserves the int nature. What you need to watch out, though, is that if you're doing division, an integer minus an integer stays an integer, and that's a problem because integers divided by integers, if you don't account for the decimals, they can have rounding errors. So for example, print 4 divided by 3. Oh, okay. Well, they fixed that bug. Okay, well, this makes me look bad, but they used to be an error. I think in the modern versions of Python, they might have changed it. But it used to just be 1. In any case, it could still come up in weird cases, so just be aware. The best practice, if you're doing division, is to turn your integer into a float. So I still would say that the best practice, if you're doing this division, is to make one of them a float, because for sure, your result will be a float. That's the only way to be sure. Otherwise, I would have expected this to have just been 1, and then 1.33 in this other version. All right, so in all programming languages, you almost always have an int, a float, and a string. What's really very important about Python are the next two concepts, which are lists and dictionaries. So my list equals, it starts with these square brackets. You always start and end with them, and it's a set of values in an order. So let's do first comma, second comma, 3 comma, I think my int is 4. So my int we'll put there, just to make it confusing. All right, so my int exists. We can go ahead and print it. For these, you definitely have to have the string wrapper. You'll notice I didn't need it for simple arithmetic. It was able to kind of infer it, but it is best practice to wrap it in the string. What the string does is it takes your object and it tries to force it into being a string as best as it can. It's kind of guessing, but it's pretty good. So generally, that's what you do, is you just turn it into a string. So we see that, okay, I forgot that my int was 4 up here, but then it was 1 down here. So, okay, so first, second, 3, and 1, so be it. But that's what my list is. My list now, you'll see, is a sequence of values. Now that I have my list, what you need to know is that you can access the individual elements of the list at each index. An index is its location in the list. So let me give you an example here. So we're going to print the value of my list, and then I can refer to a specific index. I'm going to refer to the first index, and what you'll see is that the first index is actually here. And what you want to know about almost every programming language is that indexes start at 0. So if I press the up button on my controller, the up button, it brings up the command I just ran. That's a good time saver. And then I'm going to edit it and show you the 0th element in the list, and you'll see that's this first. So this is very important, being able to access your lists. So now you know that you can access any element of it. And now Python does a lot with lists. It does a lot with lists in the next topic we're going to talk about, which is dictionaries. But dictionaries are just more complicated lists. These lists let you do a number of things. So first of all, mylist.pop. Let me just go ahead and print that. Pop pops off the last element of the list. So the last element was a 1. It gives a that. I think, let me see, my list. Yes, so pop actually removes it in this case. So if I want to store it, I'd have to capture it. You can also append. my list dot append. I'm going to change that to 4. Now, in the Python command line, in this interactive terminal, you can just like write the variable name, enter. It will try to print it for you. So just be aware that's just a convenience function. Best practice, especially in code, is still to write the print. But I'm just going to type enter to save time. So here we have first, second, third, fourth. We have that list. So we have pop. We can also, I do want to show another way to index it, which is you can index starting from the back going left. So the last element in the list is the -1 element. So -1 you'll see is 4. Likewise, if I wanted to get the second from the last, I could do the -2, right? And so this is really handy if you're like, give me the last 4 or something, or just give me the last one. I don't really care what index number value. I just want the last one. You can either iterate from left to right till you get the end and then just get the nth index, or you can just start from the back and work the other way. Now my lists can be very commonly turned into other lists. So let's call it my subset list equals, and I'm going to say my list, and then I'm going to access not one value of it, but I'm going to access a range. So I'm going to access a range using this syntax where I have the start index and the final index. The thing to know about the final index is that it is not inclusive. So you do include the first one, but you go up to but not include the last one. So we'll go ahead and just print that. So print my subset list 0, 1, and 2 are there. It's stopped at the 3. So that's just what you need to be aware of. But this syntax is very helpful for creating a subset. I'm going to go ahead and append my list dot append 4. I'm going to put 4 back in there. Oh, my list. Right. So when I created the subset, I didn't actually modify it. I think I captured a part of it and set it equal to this variable. But when I appended 4 again, it was adding it to the original list, which wasn't really changed. Go ahead, Olivia.
Do you mind enlarging the screen so I can get a screenshot of what you have on it? Like,
Yes.
you can just make this full screen.
Like that?
Yes, and then if you could maybe zoom out to back to the resolution was at.
Okay, give me a second. I want to set this up a little bit differently.
Sure, thank you.
How is that for font size?
That's good, yeah.
All right.
Okay, great, thank you.
Yep. And all right. So so my list is this, and we had just done creating a subsection. I wanted to show you also, because this is also a very common thing you'll see, is going from the 0th to the minus something. So let's say to the -2th of it. We'll say my other subset equals that, and then print my other subset.
Oh, one other thing.
Hmm.
Would you mind turning this into like a text file at the end that I can sort of just link to this, the notes so people can just scroll through that?
Do me a favor, before we close the meeting, remind me again, because I know my human behavior. I will close this tab immediately and lose all of this progress.
Sure. Yeah, no problem.
So I guess that for sanity, I can copy it and copy a part of it now, so we have a reference. But yeah, just remind me again at the end of the meeting, and I will do that.
Great.
Honestly, the purpose right now is not to be exhaustive of what I'm teaching. I'm trying to give you a leg up on your self-education. It's very hard to, in a single session, teach anything. We will revisit a lot of these concepts, but I just want you to be encountering this. So if you feel like you're losing it, do ask questions, but also don't feel bad, because we will come back to this, and it's also in the literature, and I just want to give you a plow through it one time. Here's setting up the premise, but do ask questions if you are really stuck. Okay, so as you noticed, I used the list subsetting, which again, there's a range here. That's the difference between getting a single index and getting a range. But now I'm getting a range from 0 to some distance from the end. And so 2 away from the end, when you look at our old list was this one, means don't include the last, don't include the one before the last, but include everything else. So 0th all the way to 3 is what we have. Then the last fundamental type is called a dictionary. And it uses curly braces. And the key with a dictionary is it's very similar to a list, but it has key value pairs. So just like a normal English words dictionary, you'll have something in the front, like we'll call it let's say first name, and then you use a colon, and then you put, oh, sorry, let me do that again. First name, and then you put the value here. We'll say Matthew, and then you can have a set of these key value pairs. So we'll say last name. The colon is what's separating the key on the left from the value on the right. Zamora. And we'll do last one, age 37, folks. I'm old. All right, so that's my dict. So again, print my dict. It's all, when you're creating these data types, especially these more complex ones, it's good to print it to see what the system thinks it is. Very similarly to how we were indexing a list by an integer value, we can basically index anywhere in this dictionary by one of the keys. So we would say, let's do print the value of my dict at the last underscore name key. Close off the parentheses. Oh, sorry. Square braces. Same way that you use indexing for lists, you also use square braces for indexing for dictionaries. And so there we are calling the key with the value of last name from the dictionary, and we're returning something. All objects in Python are basically an extension of dictionaries. Dictionaries are like, they power all the classes and all the really complicated stuff. The only primitives smaller than it are like integers and strings and floats. But basically everything is a list, is a dictionary. If you think about what we did with my list, where I said, let's say my list is A, B, C. Let's say, sorry, I had to declare that my list equals that. And then I say my list, give me the first element of that. That would be conceptually equivalent to my dict equals curly braces. Keys can be strings or integers. You can even mix them, but it would be this equivalent to this. A key of 0 with an element of that, a key of 1 with an element of that, and a key of 2 with an element of that. So basically, I've used a dictionary to recreate the concept of a list. So my dict get me the 1 value of that. But of course, do be aware that dicts are more powerful. So you could also have this be, again, not an integer. It could be a mix of integers and strings. Second underscore value second underscore value. Okay. All right. So, Olivia, go ahead.
Oh, sorry, I just never lowered my
Oh,
hand.
no worries. Sorry, just look down. I want to take a concept break. I know already that can be a lot for some people. Let's go ahead and summarize. Christine, what are the primitive types in Python? What are the kind of variable types you can have that we've covered?
Like for like wait
What,
variables in
as far as like when you create a variable and you set it equal to something, I've shown a different set of types of things that it could be equal to. Do any of them? Some of them are on the screen. What kinds does that include?
oh like when you're saying like my list or
Hmm.
like things
So like
that
my list is what? It's in the,
like you can create like your own list of things.
my list is a what type of object? It's in the name.
You like creating a list of things.
Exactly, it's a list. So there's a list. What are some of the other ones?
My dictionary, right? Is that what it's short for?
My dict, exactly,
Yeah.
which is a dictionary type.
Yeah.
The other ones include integer, float, and string. Okay, so I'll just write that right here. Variable, say primitive. Variable types. Why don't we create that as a list? There's a finite and logical number of them. We'll call it int, float, string, list, dict. And I'm just being funny here. It doesn't mean anything, but I just want to show you those are the 5 core quintessential ones. Anushka, go ahead. Anushka, I see you as hand raised. I can't hear you though.
Can you hear me now?
Yes, now I can hear you.
Okay. Can you explain like what float and string is?
Yes. Float is a really weird word for decimal. So it's anything that has this point in it and then like numbers that go on for a while. So they're fractions of a number. Does that make sense?
Okay. So like I think you said when you're doing operations like division or something, you would want to use float because it could be a
Yeah.
decimal.
From
Okay.
a scientific perspective, like in all the practical data you're ever going to run, always use decimals. There's really no reason to ever use integers. Integers are really helpful for like indexing, like go to the first, second, or third location. But as far as like I got a reading from a tool and its value was this, and I want to like average that, always use floats. They have more precision than integers.
Okay. Okay. And what are strings?
Strings are lists of characters. Which are alphanumeric characters. So
Like a word or like a list of numbers?
yeah,
Oh, okay. I see.
anything like that. And they're by convention, they're in these double quotes. That's how you can tell them apart.
Okay. Okay.
So we'll get
And you
into.
said
Go ahead.
You said that like lists and dictionaries are different in the way that like dictionaries are more powerful, like they can do more things.
Yeah,
But
dictionaries fundamentally have
I mean, we just treat
value pairs. Yeah. Go ahead.
Like, do we really have to know the distinction, or do we just treat them both as the same thing?
I'm
Or are there
afraid
scenarios where
you
we
do
would
have to know the distinction. It's, however, a very easy distinction. Basically, a list doesn't have keys, right? But it does secretly. The keys are the index locations, right? So a list is like location 0, location 1, location 2. But if you look at how you're declaring it, you'll see like there's no key value pairs, it's just values only. So basically lists are the values only, and dictionaries always
Oh,
have to have a key value pair.
okay. Yeah, that makes sense. Thank you.
Sure. Okay, so there's a few things to know already, and especially you'll see this when you compare to other programming languages. Python is the technical term is duck typing, but what it means is that it doesn't really care what type of data your object variable name holds, at least until you try and do something weird with it. So, for example, by convention, I've been saying my int equals 1. That's because I am declaring the name of an integer that's useful for the programmer, which is what you want to do. You want to make your life as dirt simple as possible. I actually recommend writing the longest variable names that make sense. So, for example, instead of my integer, I would say my count of classes or something. So I'm counting my classes. I have 5 classes this semester or whatever it is. Help yourself out. Give descriptive variable names. But going back to the my int example, my point is that it's holding an integer now. I think there's a one of these special Python things is called type. And if you call it on a variable you don't know much about, it will tell you what type of object it is. If we do type of that float, it was a float. But it doesn't care, right? So I could, if I was a bad programmer, do something like that. And now type of my int is that. So like, whatever you last declared the variable name as, it's what it is. So when you'll write sequences of code, and you'll just have to keep track of what type of data it is. Things that are illegal, for example, are you can't combine a float with a string and print it without typecasting it into a string. Typecasting means changing its type from one type to a different type. So, for example, if I were to go back to our good old print statement, we know myInt is a float. So if I do myInt plus is a number, it gives me an error, and it says unsupported operand types for the plus operation, which is the concatenation of what's supposed to be 2 strings. And it's saying for that plus in your print statement, you can't join a float and a string together. This is unsupported type, so you're keeping track of it. You know what it is. So what I would do instead is typecast it. So the correct way to do that is to change it from a integer type to a string type, which again, that's what the str function is doing. Now it works. And so it turned the float into a string, and then the string plus a string, that's valid, and it printed it. Okay, the next few things. The next main syntax is it's gonna get a little bit easier now to leave command line. Command line is really good for checking things. I recommend you open command line when you're curious, like how do you like change a float or a float to an int again. You can do my float equals 3.14 and do the int of my float. That's another typecast, and it turns the float into an integer. Oh, okay, so that's what int does. Like you're running a quick test. That's the best use for the Python command line. Going back to another concept, Python is dynamically interpreted, meaning like as you push enter, it runs. It also runs from top to bottom. A lot of other programming languages aren't like this. C and C++, you write the whole file. You have to compile it, which is taking it from one data type to another, and then run it. This you can kind of, as you're typing it, it compiles every line as you push enter, basically. It's a little, I like that a lot better. It's a lot faster to give you feedback. But what we're going to do now is we're going to open up an IDE. The most common IDE these days is Visual Studio Code. It works with pretty much every programming language under the sun. You start by creating a folder for your project. I recommend having like one place on your system where you have project folders. Just go ahead and create a new folder. Call this demo project. Doesn't really matter too much. Select it. And so the very first thing you do with your IDE is you just open a folder. I have over here all the files. There are no files, so let me create one. Python files end in a .py file extension. So I'm going to call it first_script.py. Enter. Now it's created it for me. In VS Code, a lot of times with these editors, you have to do like file save, file save, file save. There is a setting I really recommend. It's this: if you go to File, there's this auto save. 100% get that. Like first thing you do when you install this is just enable auto save. What it will do is it will save this file as you type it, so you don't have to keep saving it. It's best for everybody's sanity, because a lot of times you forget to save. You run it, get an error, you're like, oh, I thought I fixed that already. It's just you didn't save the file. So just save it with the auto save. Your life's a lot easier. We've already covered setting up things, so let me just reiterate some of that. So we have my int equals 1, my float equals 2.3, string 1 equals hello, string 2 equals world. All right, so now I want to introduce a new syntax. So let me get this. Olivia, how is this for font size? Is this a good font size here?
Yeah, this is good.
Okay. I'm going to introduce a new one, which is the if statement. This is our first time comparing. So let's do I'm going to do float 1. I'm going to do my float 2 equals 1.03. I'm going to do an if statement. If my float 1 is greater than my float 2, you're going to see me like auto-completing words. That's me pushing the tab character, especially in the AI world, but even before the AI world. A lot of these IDEs started to accelerate your developer by suggesting something. So my float, you'll see that's suggesting a few things here. If you select one and push tab, it will fill it in for you. So like if you see stuff like fly onto the screen without me typing it, that's why. So I'm doing a comparison. Is float 1 bigger than float 2? If true, it will execute this. Otherwise, it won't. So we'll do a print message here saying my float 1 is bigger. Okay. And then at the very end of this function, I'm just going to go down to the bottom and say print end of script, just for the heck of it. Now, this file, I want to show you the classic way of running it. So I'm going to go back to this command line. Each operating system has a command for clearing the screen. In Windows, it's CLS, which is clear screen. I believe in Linux and OS, it's clear enter, but it doesn't matter. It's just a convenience thing. All operating systems, however, use the CD for change directory. So what I'm going to do is I'm going to navigate. If you remember, this is the folder that I'm currently in. And if I do dir in Windows, it lists the directory. In Mac and OS, it's ls for list directory. But I'm going to do dir, and then I'm going to change into my projects folder. Again, everybody's system's different. Just have a place that you know. Probably a good idea to have it not too far from this path. Otherwise, you're just changing a lot of directories. And then I think we called it demo something.
Does the clear screen get rid of the previous code that you had?
Yes, Olivia, it does. Well, that's what video recordings are for.
No problem, yeah.
Yeah. We're going to stop using the command line as much. We're going to try and use more of these files. So I'll start making the files more available going forward. But yeah, sorry, mistake one. All right. So yes, dir Python, dir's listing directory in Windows World. I see that I have one file in it. So as you recall, when you when you write Python enter, you're really calling python.exe, and you're really calling the full path to it. But by convention, you're just calling the Python. And I also mentioned that after you call the executable, you can pass things to that executable. So the thing that I'm going to pass is the file name. So parameter one that I'm going to pass to it is a name of the file, which is firstscript.py. I'm going to push enter. It's going to run. It's going to print my print statements. We'll come back to that in a second. But what I want to make clear here is that firstscript.py is a file on the system. How did it know where this file was? Well, when you launch Python, which let me just do that. Python, I'm going to import a library for working with the operating system. I'm going to do operating system get current working directory. It shows you what folder your program is running from. Everything is running from a location. And so if you don't pass the full path, it will implicitly use the location that you launched your Python from. So implicitly, it knows that firstscript.py was in this location. If it's somewhere else, that's not a problem. Let me just change directory all the way up to C level. Dot is go up a level. I can still do Python, but now I need to pass it the full path. So I'm going to go into the IDE. By convenience, you can right-click and do reveal in File Explorer. It'll show you where. I'm going to go up to this URL bar, cut the path, and then paste it, and then finish it off with the file name, which is first_script.py. I'm going to go ahead and run it. So I am able to run it even though I'm not in the right folder because I'm hard coding the absolute path to the file. So you either always hard code the absolute path, or if you're doing what you most commonly see, which is this relative path, just make sure you're in the right directory when you're running it so it knows where to look for it. All right, but I'm going to go ahead and change directory back. By the way, you'll see that when I passed it this path, it's best practice not to have spaces in the names of your folders because it makes passing these things more complicated. It tries to treat those as like separate concepts. Programmers get in the habit of using underscores, or modern operating systems do dashes okay. But just don't do spaces. If you do spaces, you have to put everything in a quotes. And so I'll just show you. If you have spaces, just put just make sure the thing is quoted, and then the spaces are fine. But that's just a small detail. All right, let me, for convention and to save space, just change directory back to our project folder, dir. Oh, yep, I see it. Now let's explain this. This is what I want you to get in the habit of, is launching it from command prompt. But there is a terminal built into most IDEs now, but you have to kind of enable it. So I'm going to go to view. Let me see up here. Terminal, new terminal. There's in Windows, there's like different types of terminals. I'm just going to tell you that command prompt is the one we were just using. It's the one I recommend you use. The default's PowerShell. Just don't use it does the same things, but it's like a different syntax. So just ignore PowerShell. Try and use command prompt. It's the older one. All right, so I'm going to run the same thing here. You'll see the same results. Python first script.py. My float is bigger. Going back, we're at this if statement syntax, and it's looking at this here, and in fact, we do see that float 1 is bigger. Another syntax is if it was greater than or equal to, you could do that. If it's less than, it won't run, right? It's just we see that we're skipping this. So let me show you the second part of if, which is an else. Else print. Nope. It's smaller. Something like that. And then another one, like you could do a special case, say you could do else if, and then you could put another if statement here. So it'll try and find the first one that makes sense and then run it. So we'll say else if my float 1, say if it equals 3.14, print that's pi. Now let's go ahead and fake it so that one does run 3.14. So 3.14 is less than 1.03. That's false. So the first one is not run. That's false. Else if this one is true, then run that. Else in any other else run this. Otherwise run that. And you could have multiple of these if else's. So you can see how like already we have a very flexible way of branching. If you have 5, 10, 15 if else's, you could just cover every possible scenario. And that's fine. Like that's very valid and appropriate programming in most cases.
Do you mind zooming out here so I can get a screenshot of everything that you have so far?
Yes.
Thank you.
How's that?
Yeah, that's good. Thank you. Got it.
Okay. All right. All right. So the next thing that we're going to cover is loops. So if is great, but if you have like 1,000 things to check, that's a lot of if else to write. Much more commonly is that you'll have like all of your data in a list. So let's create our list up here. My list equals best practice is when you're creating these nested things, whether it's a quotes or a list, start by writing the front and last characters so that for sure they exist. Oftentimes you'll like write the first one, start writing your things, and you'll forget to add the last one. You'll see that modern IDEs have like red squiggles when there's like a hint that there's probably a syntax error. If I were to run this, it will give me a syntax error, and normally it's pretty good at telling you what line it's on, line 8. So okay, fix that. But again, best practice is just avoid the errors. Start by having the front and ends, and then filling in the values. So let's do a quick list. Dog, cat, mouse. All right. So let's go into our thing here. I do actually want to go back to if. There are ways to do other things here. Let's just add a few more examples. Let me do, let's intercept this. So only show pi, only show this if this first one isn't true. Else if, let's look at my float 2. And what I want to do here is it greater than 1? No, is it greater than 1 and my float less than 1.05, which is true. Print found the exception. Up, enter, found the exception. So it got to this one, it found one, it didn't need any of the others. This introduces and. Likewise, there is or, you can probably see. So we'll say if it's, let's say it's less than 0.001, or it's less than that, which should still be true. And then the last thing is I want to show you that you can put these in. You can use parentheses similar to algebra, and then in that case you can actually combine these. You could say false. There is actually one primitive I forgot to tell you, which is true and false. It's called Boolean. So my Boolean equals true. This is a comment, and I could say, or this could be the value of false. And so I'm going to say else if false and this. Now this we know is true, right? We've already seen that this is true. And so you're saying false and true. False and true is false, right? So this should not run. Let's test that. It does not run. We get to the one below it. Okay. So just be aware of that. You can have like all kinds of like nested parentheses. If it's really short, you see that you can like by convention skip it. If you're just concerned about it or just really want to get your algebra right, there's nothing wrong with just adding the parentheses. It's not bad syntax. It's fine. Just make sure you're doing it in the right order of operations, of course. All right, so going back to loops. So the most common loop is really the for loop. So the most common type is iterating over a list. So let's do a few things here. So let's get the size of my list. So my list up here, actually I'm gonna just move this down so it's closer. My list is that. So let's do print size. Here's an example of I want to go back to Python to check something. So Python, my list equals 1, 2, 3. Is it size of my list? I don't think so. I think it's length of my list. Yeah, no. My list dot length. My list dot size. I'm doing something crazy here. All right. Everybody should be aware of the modern era. Just ask Copilot. This is extremely valid. I absolutely recommend you ask Copilot in all parts of your Python learning, but only for simple stuff. You want to think through programs, but for simple stuff. So how to get the length of a list in Python. Just remind me. Len. Len. Okay, so len of my list is how you do it. Okay, that makes sense. So let's print so let's get a variable called list length equals the len of my list. Okay, which this should be an integer. And then let's do for x in range 0 to an end value. So it's start index to end index, and then the end index, same way as the range, is non-inclusive. I think list length is what I want here. So I'll say that list length should be 3. This is asking for a range that is the values up to, but not including index 3, i.e. the last index would be 2, or mouse. All right, so this should be proper syntax. There's something that I've done in the if, and I'm going to continue to do in the for, which is this indenting. Python is extremely indent sensitive. You basically, everything that is run under these conditions has to be indented. So when this for loop is running, it's running the block under the indent. If the if statements, it's everything under the indent. Indent can be either 4 spaces or tab. I use tab. Whatever you use, be consistent. I believe like VS Code, like I'll press tab, but it actually is just auto converting it to 4 spaces. It doesn't matter. The only thing that matters in Python syntax is that you're consistent. So one file can use either type. Just make sure you're always indenting the same way. So I'm going to do, we're in the for loop. So let's just go ahead and print a string that says current value is : space. I'm going to hit the string. Now I have this x, and x is a list of integers going from the 0 all the way up to this top value here. I can print range value is plus the string value of range from 0 to list length. We'll see what that is in a minute. But going back down, I know that it's the index, and it's setting it equal to this x value. So I'm going to say, get me the value of my list at the index x, and then just print that, and it'll loop through the list to do that. So let me go ahead and go back to this, and we'll do Python for sprint. You'll see that range value is a range between 0 and 3. And it proceeds to print 3 lines, one after each other, at each location in the list index. Let me take a pause here for a check. Are there any questions so far on lists or the for loop or the if statement? Okay. Let me ask Suhan. When you have a list, what is the index number for the very first element in a list? How do you access that very first element? What number do you use? And Suhan, you're muted.
Oh, sorry about that. What was the question?
The question is, for the very first element in a list, what number do you use?
It's usually 0.
That's right. Let's
Well, it
move.
can depend on the language too, right?
It can depend on the language. I can't even think of a language that uses one. I believe those are very old, like 1980s languages, but perhaps they're still out there. They're almost
Yeah,
all
I've
there.
used some that use 1, but
Okay.
Python uses 0.
Yeah, it can happen, but yeah, just be in Python it's 0. All right, and then Angela, after you do this colon in an if statement or a for statement, what's the very next thing you have to do before you start writing your code? Like, what do you put in the front before you start writing your next line under an if or a for statement?
Let me see.
So like if it looked like this and my cursor is here, what's the next thing I'm going to add on the line below it? So I'll give you a hint. When you're writing in these languages, there's this concept called nesting, and nesting is like you have to have blocks of code that are grouped together. So how does Python group its blocks of code? I'll restore the line so you can take a look. So what are these things right here? What is that doing?
Is that it's making the indent?
Exactly. The very first thing you have to do is indent it. And likewise, like I didn't have to have just one line. I could have had more than one line. End of that line, right? And so if I run this again, now it's just doing 1 2 1 2 1 2. But everything that runs inside this block has to be on the same level of indentation. By convention, it's 4 spaces, or a tab. Just whatever you're comfortable with. I use tab. Is that clear, Angela? Do you have any questions on that?
Yeah, now.
Okay. All right. So this style of indexing is a very old style. You'll see this in like C languages. There's something to be aware of that Python uses pretty heavily. It's called a Pythonic style of development, which just means like you're using Python language to its fullest. So I'm going to show the same example, but treat the list as an iterable. An iterable is something that you can iterate over. Iterate means move through a sequence, right? So I'm going to rewrite the same thing in a very Pythonic way, which is for list underscore element in my list, colon, print, this is at element, colon, space, plus the string of the list element value. Let's go ahead and run that. And you see this is at element dog, cat, mouse. So it's doing the same thing. In the top way, it came down to using an index in the list. In this format, it's basically doing the same thing. It knows that my list, that this list type here has a sequence, and then therefore each loop it's declaring this list element variable to be that element in the sequence. Like it'll iterate through each of the elements, running the loop for each element in the list. Olivia, is that clear? Is there any? I know that's kind of complicated. Does that make sense?
I'm so sorry. I was writing down a note. Can you repeat that again?
Yeah. So this is called using an iterable, and it's a syntax where instead of using indexes, you're just saying for element in iterable data type, and in this case, a list is an iterable data type. For element in list, then at that point in your code block, your variable name here is
Oh, yeah.
declared per element in the list, and it's running whatever element it's currently at. Does that make sense?
Yeah, that makes sense.
Okay. All right. Okay. So the last one that I'm going to cover is just a separate type of loop, which is a while loop. These are not common in most types of applications that we use. The most common use where you'll actually see this is infinite loops, which sometimes you want infinite loops. So if, for example, if you have a program that is checking whether something is added to a website, you just want to check every 5 minutes. So what you'll do is you'll say, while true, do this stuff, check a website or something, dot, dot, dot. And that just runs forever. So that's commonly done, but you can have it be conditional. So let's say is underscore found equals false. I'm setting up a precondition. I'm saying is found is false. So while not is found. Now not is using. Hold on. Is it that? Yeah, I think it's that. I think you just say the word not in Python. I get my languages a little bit screwy sometimes. While not is found. Do some stuff. Pass it doesn't do anything. Pass is like I'm just kind of doing a placeholder for my code. I'll circle back to it. But I'm just saying while not is found, do this stuff. Okay, so now let me go ahead and fill some stuff in for it to do. So let's also do the index style of so let's say current index equals 0. You always start at 0 in Python, so let's just set that. So let's do my list. Go ahead, Olivia.
Yeah, sorry to interrupt. I was just going to say it may be good if we continue this like at the next meeting or something, because I know it's getting a little bit late. So we have some people that may need to leave.
Yeah, I'm wrapping up. I was gonna close it up.
Sure. Okay, great. Thank you.
So while not is found, we know that it's false, right? And so not false means it turns it into true. So this is currently running as true. Then it does something, and the thing that we're doing is we're going to get my value is the current the element in the list currently, and then we'll say if my val if my val equal mouse, which I believe is our third element, say print I caught the mouse. I'll do else print failed. Now this will run forever unless we remember to update is found. So in the case that we found our thing, then we say is found now equals true. All right. So, okay, I have a logic loop error. It's running forever. So what did I do wrong? Kernet is not a thing. Oh, right. A few things I messed up. Current index, but I also have to increment the index. So like index is always going to be 0 unless I do increment, which is current index equals current index plus 1. So it'll actually, every time it loops, progress. So there's failed, caught the mouse. So those are honestly, that's like the heart of what you need to get started. There is a few more advanced concepts involving functions and classes that are like the next things that we should definitely cover. But as far as like the core of the language, that's largely it's variables, primitive data types, controlling your code with if statements, controlling your code with loops. The next thing that we'll get to are classes and functions, which are just ways of reusing blocks of code over and over, so you don't have to write the same types of things when you're calling something that does the same thing. So let's go ahead and wrap up there. My recommendation is during the course of this week, please try and make as much progress through that Python PDF. Again, chapters 1 through 14. Whatever you can get through is helpful.